We are definitely like discussing this even at Hugging Face while we are building like these powerful technologies. And there's a big responsibility to, like, when we try to open source some of these things, is to, like, have we evaluated it enough, or, like, have we red teamed the model? Have we thought about, like, what guardrails should we put in place while when we open source these models? And I would say that, maybe I don't see that there's an existential risk with these models, but definitely there's like more real risk of, like, just like impacting real people. One of them would be just like persuading people to, like, harm themselves. But then there are examples of other models that can, like, even like these large models that are out in the open would generate really bad and harmful text, which would, like, persuade people to, like, go, like, harm themselves, or, like, tell them to, like, harm other people. Also, like, with these models, like, becoming agents and, like, interacting with the browser, they can, like, do things that can have physical consequences, right? Like, right now you can connect it to it can work as an interface to any application. If you can order a coffee, you can also, like, order chemicals, you can order, like, a lot of these different things which could be used, like, if there's a bad actor, could be used for building harmful products.
I wanted to quickly go into, maybe just let's tee it up a little bit for the audience, and maybe open up the conversation a little bit about the work that you're doing, and then maybe we can sort of go from there, because I think it will really set the stage for the conversation about working at Hugging Face, the work that you're doing with AI, and everything in between. So maybe, do you want to explain a little bit about Hugging Face, what you do there, and maybe a bit about your background as well?
Of course, yeah. So I'm a research lead at Hugging Face, and currently I'm working on a very exciting project, which is building the open source version of ChatGPT. I'm sure everyone has heard about ChatGPT at this point, and it's this model from OpenAI that is very good to talk to, converse with. And the thing is that it's not open source. That means that you can only access it via interface, but you cannot modify it or control it or deploy it in other use cases. And so what the community was actually looking for is, like, is there going to be an open source version? And that's how, like, Hugging Face kind of became, like, front and center, right, when ChatGPT was taking off. Is that, everyone started looking up to us as to, like, is there going to be an open source version of ChatGPT? And so that's when, like, we as researchers came in and, like, okay, yes, let's build this. And the thing is that the reason there's, like, a big research component to it is because there are, like, it's not very open knowledge, or OpenAI has not been very open about how they build these models, the challenges associated with it, the finer grain details about it. So in itself, it's a research problem to figure out how much data you need, what kind of data processing you need, what works with RLHF. Is that even, like, an important component? And things like that, right? And so that's why there's this big research component to it, and that's what I and my team have been working on at Hugging Face.
You guys trying to copy exactly in terms of what OpenAI's ChatGPT is actually doing, or is it kind of different at the same time? What's the goal of this?
Yes, so the goal is to, first of all, like, learn what makes ChatGPT so much better than something like GPT-3. Like, what does it take to go from GPT-3 to ChatGPT? We do know there are, like, some ingredients or some steps, or that have been taken from, like, going from a foundation model like GPT-3 Bloom, to something that is more conversational, friendlier. And we are more or less trying to replicate those, although there are, like, a lot of decisions that need to be taken at each step. An example would be, like, when we are doing alignment with RLHF, which stands for reinforcement learning with human feedback. You generally you collect human preferences on some dimensions, and the dimensions that and OpenAI and Anthropic have been focusing on mainly is truthfulness, harmlessness, and helpfulness. And so asking people that which response is better in terms of these three dimensions. And so those are those the dimension that we also want to, like, align our models to? Are there other dimensions to be looking at? What So it basically goes into, like, almost like the model creators deciding what values do they want to distill in their model, and what do they want to align their models to.
Yeah, I mean, It's an interesting research project as well, and obviously it sounds like there's a underlying mission for Hugging Face to make this transparent. It's trying to make this as open as possible, considering the irony that OpenAI are not necessarily open themselves on this. But at the same time, I think that Hugging Face exists to really provide an open sort of platform and forum for communities to come in and build that. Can you maybe give a little bit of a backstory behind Hugging Face, especially for those who don't necessarily know what Hugging Face is? They've probably heard of, just your large AI companies, your Googles, Microsoft, OpenAI, NVIDIA, and a lot of projects as well, like Apache Spark and all those things. But maybe give a high level on what Hugging Face is, and what's the purpose behind their existence.
Yeah, so Hugging Face is a startup. Its mission is to democratize machine learning. So basically, try to make that accessible to as many people as possible. To empower people to be able to train their own models. So we have a very huge hub of data sets, machine learning data sets and models. We have close to 40,000 data sets, more than 200,000 models on the hub. We have an evaluate library that could like evaluate the model on like more than 70 metrics. We also have tools to help you deploy your machine learning model as like for to share it with the public. And the story behind this is that it's all started with the Transformers library. So the Transformers paper, which is sort of like the building blocks or the horsepower behind all these large language models today, was a paper that was released by Google back in 2017, and the implementation of that was in TensorFlow, which a lot of people like prefer PyTorch instead of TensorFlow. And so what Hugging Face did is to like just build that in PyTorch and make that more easily available to like be able to like run the Transformers model or anything in like a few lines of code. And then very soon they started picking up other models from research papers and trying to like open source them, implement them, and make them easy and streamlined to be used. And that started gaining popularity. And little did people know that with the Transformers paper and the Transformers research, everything's just gonna like start accelerating research in the direction of large language models. And so that's basically made Hugging Face the de facto place to like go and build off of what other people have done, so that they would just come here, download the Transformers library, and then came the dataset library as well, and be able to like build off of what was already done and then take that forward.
So who are the sort of contributors into Hugging Face? I feel like it's more or less becoming more of like this open community of people coming in and creating models, contributing data. Is that the intent, where there's this sort of sense of community and trying to encourage people to contribute whatever they're working on in that space into this community so that people can learn from each other? It almost sounds like this sort of open source initiative, if you will. Is that sort of accurate?
Yes, that is accurate. And I think you're also kind of alluding towards this incentive structure. Like, what is it? What is incentivizing people to come and contribute towards open source data sets and models? And one of the biggest factors driving this was that when you try to like submit papers to conferences to get them published, they generally ask you that, are you planning to open source this? Like, are your results reproducible? Can other people look at these? And so most of the time people used to like put them on GitHub and like put a link to it, but people eventually started figuring out that it makes it more usable, and they get a lot more popular and a lot more usage if they actually put them on Hugging Face, because of this whole streamlined process. And so obviously like when you build something and when you release something, you want more usage, and so it was just easier to share it on Hugging Face platform as opposed to like just putting it on an open source repo and then describing how to use that. So like it just became like this one-stop shop for all the machine learning needs.
It reminds me, I mean, the analogy that I immediately think of when you say that is like product hunt. It's like putting, people have their own file, whatever the latest, greatest thing is, and they're going to this one stop shop platform. And then, it just gets proliferated into the community. And because people know about Hugging Face, they all go to this community. Everyone knows that there's legitimacy and authority around Hugging Face too. So it's kind of cool that you have sort of these network effects. It's always nice to sort of see what that looks like. How do you when you started working Hugging Face? What was the culture like? What is the culture now like? What are you incentivized to do? What's your sort of day to day like? You mentioned research is a big part of your role there. When you start at Hugging Face, do you choose the projects you work on? Do you have free reign on what's available? How do you figure out what the priorities are when it comes from sort of the leadership level towards towards everyone else working in the company?
Yeah, so the culture is very different from where I was before. I was at Salesforce Research before, which was a big corporate giant. And I think the main difference was like the lack of processes. So it's like very fast moving culture here at Hugging Face. There's no process or no documentation around like how to do something, or how to say like get a laptop to work on. You go to apple.com and order it yourself. And so like there's like a lot of these smaller things, which initially it was a big culture shock to me, just coming from a bigger corporate thing where there's just so many security checks and so many processes around like how who gets a basic authenticated to what sort of groups and what sort of teams and so on, and like how what is provisioned for what account. There's just like so many processes and checks and bounds and these in bigger companies, but with Hugging Face it was much more like streamlined, faster and smoother. There's also like bias for action, so they always appreciate action compared to inaction, even if it leads to something that could be like a bad outcome. But at least like you did not just sit there waiting for someone to do it for you, right? Like it's always good to like do it yourself. So that was one thing. In terms of projects, yes, there's like, at least in the science team and the research team, which is what I'm part of, there is like a little bit of freedom around like what you work on. It should all tie into this mission of like making ML accessible and democratizing, and open source is obviously the central focus for us. Right now, I think recently we have all been like trying to like figure out like the needs of the community are trying to meet them. And so basically that is around like understanding what this large language model like ChatGPT and GPT-4 are, and can we get access to this, or can we get knowledge around like how to build these things, right? And evaluating them. Obviously there's a lot of responsibility with doing such a big task, is to like are we going to open source this giant model, this very powerful language model? It could get into hands of bad actors and things like that. So thinking about these things in itself is like a big responsibility.
I want to get into that sort of philosophical discussion later on because I think it's really important to have. Also, you mentioned about the history of the transformer library and that paper by Gould. Again, another important thing that I want to talk about. But at least for now, when you sort of within the confines of Hugging Face and you're working there with your coworkers and your colleagues, and obviously you have that community interface as well. You're engaging with the community on a very frequent basis. What is the what's the dynamics like when you're working on these types of projects? Is there very free flowing when you talk with your colleagues on sort of things and features to build in, or is it more so very processed wise like Salesforce, where there's a product roadmap and then you have to figure out exactly how to get there, or is it very different?
Oh, it's very, very different. It's very open-ended, very, async, because we are all distributed across many time zones. So we all work from different time zones, very decentralized. My boss, like Thomas Wolf, he's one of the co-founders. He also does coding, also basically debugs with us and everything. So it's very much like, kind of taking your own initiative and doing things yourself, as opposed to like relying on processes or figuring out like oh, should I like wait for this thing to get completed, is this okay to ask? Like it's you everyone is empowered to like go ask the CEO or like the legal team on like hey, like can you get me this document, or for like whatever thing you need, right? And so it's very flat in that thing.
Very cool. Let's quickly talk about sort of your journey a little bit because I think that's really, it's exciting for me to learn a bit about your story as well, and sort of how people that I've met in the past have come into the AI space. Everyone has their own different stories. What's yours? Maybe let's sort of quickly, go back in time. What sort of got you interested in AI, and how did you, uh, move from one company to the other into Salesforce and now Hugging Face? What was that sort of that journey like for you?
Yeah, so actually, my journey started way back when I was like sixth or seventh grade. And my father had a big hand in it. He used to always tell me about stories about, artificial intelligence and how it is different from software that we have. This was 2 decades ago, right? And so he actually used to tell me about this, and he's like, "Oh, you might want to like look into that because that's going to be big in a decade or so." And so I was like, "Okay, sure." And basically I just followed the pathway that he sort of like showed me. And then when I was in my undergrad back in India, it was like I was in my junior year. I actually wrote my first paper at that time, which was like building this very small neural network of like 2 layers to solve the tic-tac-toe game, which is this 3 by 3, but it could like generalize to n by n. And I just like wrote this very simple algorithm which could like always make sure that the computer wins or it ends in a draw, which is like a neural network. And it could like generalize to any n by n matrix. And so that kind of was like very fascinating how like the simple thing could be able to almost like emulate a human being trying to play a game and try to like game them in different ways by just being this like a very simple two-player game. And so that was like very motivating. I took this class back in like my in my junior year, like on neural networks and also in artificial intelligence. And those two were like sort of the building blocks behind that. Then I came for my graduate school at UT Austin back in 2012. Then I first did my master's and then I continued doing my PhD starting 2014. And I took the natural language processing class as part of my coursework. And over there, I started like learning about like language and linguistic structures in language and how we can like train these models to be able to like form these trees and like understand like the intention behind what the speaker is saying or like what the intention the speaker is trying to communicate. And so these things were like really very exciting to me, and I was working on them way before transformers came out. And then when I graduated, this is right when like the bird model transformers and all these were released. And at that time I joined Salesforce Research because that was like basically MetaMind became part of Salesforce Research, and MetaMind was focused very much on NLP. And so that gave me an opportunity to work on explainable AI, and that was also what my PhD dissertation was on, is trying to understand what these neural networks and why they're predicting what they're predicting. And so I started off by taking this GPT-2 model at that time and making it like generate explanations for a certain input. So you would ask it things like, what would happen if I push a book off the table, and then it would generate reasoning like oh, it would fall because of gravity and like that. So like it was trying to like get this sense of how the world works just by reading text. And that was like very amazing because then I could use this and give it to another downstream classifier that could use that reasoning and perform much better on the task that it was doing. And that was like something that kind of gave me a really big motivation to go in this direction of trying to like really understand what these large language models are learning.
Was it? I mean, for me, I I've exploring AI myself, right? It's a bit of a rabbit hole, and you definitely learn a lot, especially with so many technologies, frameworks, models coming through. Was it? Yeah, and you mentioned obviously that little story of yours where you were able to understand and sort of get excited about that. What do you speak to sort of the current generation where there's a lot of models that are already pre-created for you? They're sort of there to be used, and that's great because it's democratized AI, which is fantastic. But at the same time, there's a lot of people coming to this space not knowing the fundamentals. So can you sort of maybe speak to how important is it to actually understand the basics and the foundations of learning about AI? Because for many people, they don't have the time, they just don't have maybe the resources, and they only see what's been given to them. Is it still important to understand the foundations?
Yeah, it's extremely important to understand the foundations, and I can't emphasize that enough. And like, just to give you an example, for like, when earlier when I used to tell someone that I'm doing my PhD in computer science, focusing on AI, they would more be like, the jokes would be like, hey, can you fix my computer, can you fix my internet, right? And so, but the thing is that, people fail to understand that, a lot of computer science is just math. It's like we are doing like, programming, or all these things are just tools to get to like what your goal is. So you could like, you could may or may not be very good at programming or software engineering for that matter. But you could like, if you had like a very strong math and statistics foundation, you could actually be a very good AI researcher even without being good at programming. And so that is kind of like highlighting the importance of like, the foundation of how backpropagation work, transformers work. And like, it would be very hard to like, be able to like, survive long term. And like, and like you said, it is a rabbit hole for sure, right? And so like, being able to like learn and like, be on that journey for a very long time of learning more about AI without knowing like sort of these building blocks of like, what goes into, say, backpropagation, how does the chain rule work, what is transformers, what are like the equations governing that, and so on. So yeah, I would say that those are like extremely important.
When you were in India studying AI, I know that in Australia, in the US, maybe I would say 10 years ago, I remember studying some basic AI courses. This was just, one, two layer, three layer neural networks and using sort of CNNs and that which is convolutional neural networks. For those who aren't who don't know what that is, but I know that obviously the space has completely changed and really flipped on its head over the past 10 years. What was it like in India? Was there interest in AI, or was it still traditional in sort of going through the pace of traditional engineering, traditional computer science? What was the interest and the spark for AI in at least in India at that time?
Yeah, so this was like back in 2011, 12, so like over 10 years ago, when I was in doing my undergrad. And back then, I would say, so the both the courses on artificial intelligence, which we used the textbook by Peter Norvig and Stuart Russell, which is a very standard one over here as well. And the other one on Intro to Neural Network. Both of these were elective courses, so they were optional, and they were not something that, and most people wouldn't take. It was like a very small class. So I would say like, even though there was awareness for AI, and like, there were maybe people using it, was mainly very rule based, and using like, very simple classifiers, and like, even like very simple heuristic algorithms, which are like mostly rule based learning, not even using much data to like find patterns in them. But I think it was only in 2012 or 2013 when this whole ImageNet moment happened, and the AlexNet came out, and things started taking off since then. So I would say like, yeah, back in India, like things were slow, but now I know that they're picking up very quickly, and things are moving very fast over there as well.
Let's quickly go into maybe some of the interest that you have within the space of AI. I think it's pertinent to understand a little bit about what you're working on right now, and especially on sort of model creation. I think creation, model understanding, and making sure the models itself are robust is incredibly important. Can you just give a high level first of all about what is an AI model? What's the purpose of an AI model, and what sort of goes into that?
Yeah, so an AI model, you can think of it as just a very complex function. It takes in inputs and generates outputs. So the inputs and outputs could be anything. And the function is just like, manipulating those inputs and then producing the output based on them. but on much higher level, that was more formal definition, but on a higher level, what it's trying to do is that find patterns in data. So you give it some amount of data, and then it looks at patterns or tries to learn representation of the patterns. And then when you give it new data, it uses what it learned from the past patterns and like the things that it picked up to sort of like just extrapolate and make predictions on that. So that is what, at a very high level, what AI model is.
So can you give an example? So it would be like, so for example, text. For example, how would can you give an example of a text-based uh, AI model? Obviously there are everyone knows about LLMs now. So what's a how do you sort of whatever you just explained? How does that get applied to sort of these text-based models that everyone knows about?
Yeah, so I think the very simple example would be like a sentiment classifier. For example, for movies, like you could give it input on like movie reviews, and then ask it to predict what the sentiment is. Like, is it a positive, negative, or it could even be more like a continuous scale, like, predict a score based from like, 0 to 10 on what rating the movie should get. And so those are the outputs expected. The input is obviously the reviews, and so when you train this model, it's what all it's trying to do is find patterns that makes something a positive thing or gives it a score of say 8 or gives it a score of 2, for example. And so it tries to find like, are there specific words or sentiments that are there in this input that is leading to that particular output. And so trying to like, tune its weights in the sense that, figure out the right set of like, it's like, think of them as knobs, like, the right set of the how much you need to turn the knob, and the right setting that would lead, like, given this all this training data, would lead to exactly the labels that you provided that with, right? And so that's what it's trying to fit the function to, is to like say that, okay, now like my function fits almost perfectly on the data that I was given, which means that now that I get a new data point which I have not seen before, I can use this function, but and like say that, oh, does it fall on this side or that side? It's like a very simplified, like a linear function, and then just make that prediction on like, just based on like what it has seen in the past.
So does that mean that if you're trying to massage the data in order to fit the function, and obviously there's linear, there's non-linear, and linear and non-linear, but in any case, the value, the quality of the data itself has to be good, or doesn't have to be good? Because I'd like to understand a bit or more about what goes into the model itself, and does that predict the output of the quality output of that model if you have bad inputs? Or can it be that even if you have bad inputs, you still can produce a reasonable result? Because I want to understand a bit about the model creation phase, and especially about constructing that model from valid input, and from both that's input that's been clean or unclean. Can you sort of speak to the quality of the input data?
Yeah, so I think for that we would have to like go more into the types of learning. So there's something called, I think so far I've just been talking about the supervised learning, wherein like you are given some data and you have labels, right? And so assuming that the labels are really good, like me, they are like good quality data, so that whenever the sentiment is actually positive, the label actually does like, describe that it to be positive, and when it's negative, it describes it to negative. But you can imagine scenarios when it's like noisy data and like not all the labels are correct, but you still expect the model to perform like robustly enough to be to predict the right reasonable output. That would be supervised learning. And then there would be something which is the self-supervised learning, which is what like a lot of these models are trained today, is that you just give it a lot of text and then it learns on its own, like by but a lot more data, as to like it teaches itself to like what the task is, or what are we trying to do. And so that is how, like, when you give like a few short examples of something and then give another example, and then it now tries to predict like what the new label should be. So this is kind of like so in the self-supervised learning, the features are decided by the model, like the model decides like what are the feature. In the supervised learning case, like, which if you're using a neural network, you kind of giving it the outputs, and so it also knows like what features are important in that case, like the looking at the labels, or like trying to figure out which words are related to what label, and so on. So I think these are like the two scenarios, and so on both the cases, the data quality would definitely affect like your training, and finally also affect your downstream model performance.
Yeah, that makes sense. And I think for the most part, the unsupervised learning or the self-supervised learning is the one where you mentioned about that the data in and of itself, you're training on that data. It's trying to learn, self-learn from that and be able to produce these outputs and sort of continue to have that feedback loop and try to continue to enhance the output of its data. What about robustness? And when I speak to robustness, you know, it's I'm really referring to the extremities of where you can actually push the model, the sort of the edge conditions, the boundary conditions. Is there some value into assessing the quality and the robustness of a model, and how do you actually even make sure that the model is robust in the first place?
Yeah, so I think what you are referring to is called stress testing, is that like trying to like give it the most adversarial example or the most edge cases and see if the model can handle those well or no. So yeah, those are definitely very important, especially now that the models are getting so much better and almost at human performance and many of these tasks. The way Another way to like look at robustness is to just look at the worst case accuracy. So basically look at how the model is performing on the data slice that is probably not very dominant during training, or look at like as opposed to looking at the overall aggregate performance of the model, look at how the model performs on a certain data slice. I think just to give you an example, very simple example, suppose that you train the sentiment classifier on movie reviews from IMDb, and they have, suppose like the average length of movie reviews is 200 words, and now you want to like see if you just gave it a movie review that was 20 words long, that's it, is the model able to handle that? So that, because the model has not seen very short reviews, is it able to like is it robust enough to handle those kind of things? Because of like this could be a slice of data, like a data slice that just looks at how does the model perform on short reviews, right? Compared to like on average most of the data falls around say 200 words, but there might be some data that doesn't, that falls like much shorter than that. So that would be one way of assessing. There could be various ways of slicing data. It could be like maybe like ethically inspired, like looking at particular demographics of data slices, or it could be how does the model perform on some categories that are not very dominant in training. Like for example, if you're looking at sentiment of a movie which has maybe like a non Hollywood movie, or some examples of like movies that are not in English and things like that. So those would tell you like, oh, is the model robust to these, and if and what is the performance of the model on those? And so the robustness would actually be the worst case accuracy, like so if it on average it performs 90%, but on some data slides it performs only 75%, then that is what how good it is.
Yeah, right. And so for if in order to create those stressors on the model, what do you actually need to extend the robustness, to enhance the robustness? Is it just literally more data and continue to training? And once you get some sort of convergence towards this model that you're trying to fit, or is it something else?
Yeah, so a lot of it is related to data. So I think people have like looked at this idea of doing like data augmentation using weak supervision, or just like extending data sets and seeing can that help with alleviating this problem. So that is like one of the most easiest low hanging solution for that. Obviously, like using a better model is also the other solution. Is that you probably don't need a very big model for a lot of these use cases. So like looking at smaller model, like over parameterization is actually a big problem with like robustness, right? And so using like a model with much lesser parameters can also be helpful, like training it longer on the data, and like being able to like learn like something like obviously adding like things like what was I going to say the to overcome the problem of overfitting, and so regularization, yeah, that's what I was looking at. So I think those things all help with this problem of robustness and like trying to make models robust.
What about scaling models? And I want to speak to sort of that notion of like, well, okay, well, how big can a model get? And once it gets to a certain size, do certain properties start to come through? Sort of these emergent properties. Have you seen this in experimentation? Have you seen this in your own work? Because it sounds like with especially with not just the training part but the generative side of it as well, as it starts to understand itself, is that it starts to develop intrinsic properties about, and we've seen examples of this in the media. We've seen ChatGPT and many other LLMs produce answers and try to do things that weren't necessarily caught at the beginning or even anticipated. How do you speak to that when and exactly, and maybe you can explain exactly what's happening. Why is it that perhaps when these models scale to a certain size, funky things start to happen?
Yeah, so I think this emerging capabilities, it's an interesting topic because I think when you actually look at like smaller size model, and we have seen this ourselves, is that, you know, yeah, okay, they don't perform certain, like, very well on some of these tasks, especially the ones that require like math reasoning or common sense reasoning and so on. And as you scale up, they, just by like, getting more parameters and like looking at more data, they're able to like gain a lot, like, some of these skills and do better on them. For example, I think examples of emerging properties is this in context learning, right? Just giving a few examples and then being able to generalize to more examples on a completely novel task is something that happens by scaling models up. And so yeah, this is definitely that. The other example is chain of thought reasoning. And so give like asking the model to think step by step. This doesn't usually work with a smaller model like say GPT-2, but you see that it works reasonably well with these bigger models. And so I would say, like, yeah, I think there are definitely, like, we see these, but a recent paper from Stanford actually is like said that the reason for this is because we are not looking at the right metrics for evaluating these, how we evaluate these models on these tasks. And so it might seem to be like emerging, but it's just because we're not evaluating properly. So that's, I would say, there's still like not a lot of like confirmation on, like, and there's like almost two camps of people, whether, like, is it actually emerging or is it something that we need to look more into? Because I think the pace at which the this technology and the research is moving is like, it's very, every day is like a new thing, right? And so far this is kind of what it looks like. But I do see that definitely, like, with scale and data, there are definitely, like, the model capabilities do become better. I don't know if we should like term them as emerging capabilities, or like, are these something that never existed in smaller scales, versus like, now they are like really good and like, just came about when never existed, or versus they were just not, like, we are not looking at the way of evaluating these smaller models versus like the ones that we are doing right now with the bigger ones.
So I wanted to just maybe go into the notion. We spoke about transformers, we spoke about these large language models, maybe just as a high level for people who don't understand. They've heard of GPT, but they probably don't understand what the GPT stands for. Can we sort of go into pre-trained transformers, these, and understand a little bit about what are they, and how are they different from the traditional way of training these AI models?
Yeah, so I can talk about how pre-training happens, and GPT stands for generative pre-training, how they're trained. So in this, like, we the basically the big thing is that it's trained on a large amount of text, a large body of text, and the objective for the model is to just predict the next token. So token is, you can imagine them to be words, but they are generally like smaller than words, like, so they're subwords. So the model, what it does is, like, for every sequence of word, it learns to assign a probability over the options of the potential next word. And so by doing so, all it is doing is that it's trying to acquire some sort of an internal representation of the language. So think about it, like, if I tell you that this is a, and then what is the next likely word based on a lot of like English text that you have seen in your life, what is the most likely word to do, next word? And how do you complete that prefix? And so that is kind of like how these models are trained. And after this process of like just reading the, like, trying to predict the next token over and over again for lots of text, after this process is done, the model is very capable of generating text and providing natural continuation of a given text prefix. But it may not be very good at communicating, like, so when it's prompted with a question, it might give it an answer, or it might generate a series of additional questions, or it might say that, this is an important question that was asked. But it might also, like, because it is just like trying to predict the next token, it may or may not generate something that is always factual. So also, like, just to give a comparison of the amount of data that these models are trained on, because like I said, that's kind of like the biggest input that goes into like training these model. So for if a human reads like 30,000 words an hour, that would be like, and if you read for 3 hours a day, that would be like a total of 90,000. And by the way, 30,000 words an hour is super fast, like if you're a very fast reader. And then if you read, every day for 3 hours a day, in your entire lifetime, you would have read 7 billion words. And so the models today, like a model like ChatGPT or GPT-3, and these models are trained on the in the order of trillions of tokens. So just like 7 billion versus like say 1.5 trillion, for example, right? So that's like a big difference. Like it's all like orders of magnitude different. So just to like give a sense of like how much data, how much text it requires them to get a sense of like learn what language is and like understand what is the likely next word. So just to like put that into perspective a little bit.
Can you elaborate on the tokenization process? I know there's some there's a lot of content and information on sort of the creation process, the training process of these models, and a lot of the jargon circulates around sort of tokens and tokenization. What is a token? How does it work? And what does it represent?
Yes. So when you feed the input to the model, you're supposed to like chunk it so that it knows that, oh, what is sort of like this simplest, like, what is the atom, like the most simplest piece, right? And for most cases, you would just, chunk it on a white space. And that could be, so that would be a word, and the word could be a token. The disadvantage of having that is that, suppose that you had just like so many words in training, you come across a new word, and you kind of like don't know what how to like handle that because you've never seen that during training. And to avoid this problem of this out of vocabulary problem, what people tend to do is that they chunk the token at like much smaller pieces of like, so it's called a subword, so that when you actually look at it, so something like running would be like, for example, like two or three subwords or two or three tokens, right? So it like chunks it into smaller pieces that are more frequently that are more likely to occur, and then put them as a vocabulary token, so that when in the future you see some new word, like when you chunk it up, that okay, you have probably seen like seen that before, so that it's not that doesn't have this problem of out of vocabulary. And that's the thing, like why we need to tokenize, and why we need to tokenize at more like a subword level.
So with sort of just GPTs in general, though, obviously there are many applications of AI. There's image classification, there's video, there's music, there's audio, there's text as well. With GPT, a lot of this got kicked off when that 2017 paper from Google got published on, I think it's all the attention you need or something along those lines. And so attention is all you need, I believe. And I think that that sort of kicked off this really amazing evolution in this space. But was that it? Like, was that the inflection point that we needed for something like this to happen? I'm trying to understand if there's, I don't know, maybe some other alternative to GPTs that could be as performant as something like this, or was everything sort of residing and sort of sourced from that one paper?
Yeah, so I would say I think it was like it was gradual almost, like first we had like people were looking at RNNs and then LSTMs, and I'm talking mainly about text, and then like the transformers came in, and they basically saw like this overcame this problem of like the long text dependency, which is it was very like you could have like long range dependency without having to have like a quadratic or like a very complex computation. And so you could do that much faster at a much for higher scale, and be able to like look at like a lot of words at the same time. And so that is basically the problem that transformers solve. But also like a lot of these things like started working mainly because of like you probably heard of the hardware lottery, right? So which says that a lot of these algorithms and this ideas around neural networks and these LSTMs RNA existed like decades ago, way before the transformers came out. But the reason that this new innovation and this acceleration in research on these topics like picked up because like we had the hardware to actually run these computations at this level, at this scale. And that's kind of like saying that, okay, like is that like the transformers paper is definitely like crucial, but then also like having the hardware and like the the means to like run these and do these experiments is also very important.
Yeah, I think that's really key, and I think that's been a missing point from the conversation is really the foundation, the infrastructure, the entire hardware foundation to do this is now we have so much capability and so much power at our disposal and computation power that we can actually run these models. Everything that was previously known to be theoretical and just on paper is now, well, we can actually test this and experiment it out. And this has also been led by the massive incumbents in your Googles and your Nvidias, which is really cool to see. Let's quickly talk about maybe just now from a general standpoint, AI and sort of why tools like ChatGPT are so useful and not you know not just being used as a toy per se. What are you seeing in your network? What are you seeing in on your side that says that ChatGPT is something more than just a novelty thing right now? What could it be sort of in the near future?
I would say that I think it has a lot of potential for disruptive changes in a lot of a lot of domains that we have technology and software. One example is education. I think every day we are seeing like I mean, obviously there are like examples of students writing essays from ChatGPT, but then also like you people using ChatGPT as a tutor. And just this morning, I read that someone actually like was on Reddit was that someone using ChatGPT for a period of like last so many months as a Python tutor, and every day they come back and they're like, okay, like teach me this, and like it will tell you like next steps, and then what, like it basically created a plan for them, and that sounds like amazing. That's like a real application of ChatGPT about like tutoring people, helping them out, assisting them. The other thing is that a coding assistant, that is something that I use all the time as well. It's hard to like imagine coding without a co-pilot, or like something like ChatGPT where you can just throw in an error and say like debug this. So, like you could go to Stack Overflow, but also like I've seen a lot of people started using ChatGPT now for like these trying to figure out what's wrong with their code. Obviously, like a lot of people also started putting like proprietary code, which which people have from Samsung and all have figured out. So I wouldn't recommend that. But then I'm just like saying that Copilot is good. Using it as a coding assistant is a good thing. Obviously, like content creation, writing, it has accelerated a lot of like content creation for maybe like videos, images, even like new posts and like new blogs and so on, and also like reviewing blogs, reviewing documents. People have started using it as a tool to review their papers. Also in the legal use cases, like yes, assisting paralegals and all, like summarizing these like huge amounts of contracts and documents, and trying to like just make sense of like very big, very sort of jargony documents that you want to like ask the model questions about, like, hey, when did this happen, or what was the action that I needed to take from this thing, and so on. I think there's a lot of these use cases that we can see that are very real, like applications of ChatGPT beyond just a novelty.
Yeah, I agree, and it there's definitely. I mean, even ChatGPT in and of itself, and now with Bard and a few other alternatives out there, are really seeing the value of what they're doing. And you mentioned the co-pilot notion, right? And my take on this is that we've had sort of this autopilot era where they've been sort of detect there's we've used AI to help us sort of streamline our work with no intervention from us. We'll say, okay, it detects an image, it's able to capture and identify things quite easily. But now the co-pilot era is coming in, where we're now using AI as a tool to supplement us, and we're working with AI together to write code, to write documents, to really streamline our lives. So I think there's some value there, but I also feel like there's dangers as well, right? There's a lot of people now thinking about, should we slow down AI? Should we pause AI research? What are your thoughts about that? And I know at Hugging Face, there's this sentiment that we got to continue to innovate and really push the boundaries on what this could potentially look like. But has there been any conversations, maybe within the walls of Hugging Face, or maybe your own personal thoughts about what the future of AI look like from both a positive and negative standpoint?
For sure. I think, although, all these amazing things that we get out of, productive effects of ChatGPT and these LLMs, on the other side, we also have, very real danger that comes with this, right? And I think the most common ones are like deep fakes, or misinformation or disinformation, even like things like data privacy, and consent on, the consent on the data, cybersecurity risk, copyright issues, or IP issues, and also just disparate impact. There was, with watermarking, for example, it seems to work well, but then if a native speaker is writing, the detector would actually say it was generated by ChatGPT or GPT-4, the native speaker English, versus someone who's fluent in English. And so again, you can see disparate effects of even the watermarking, or the detector, on marginalized groups, right? So I would say yes, we are definitely discussing this even at Hugging Face while we are building these powerful technologies. And there's a big responsibility to, when we try to open source some of these things, is to have we evaluated it enough, or have we red teamed the model? Have we thought about what guardrails should we put in place while when we open source these models? And I would say that maybe I don't see that there's an existential risk with these models, but definitely there's more real risk of just impacting real people. And one they could be so I can give many examples. One of them would be just persuading people to harm themselves. And I've seen this, although chat gpt and GPT-4 now are very good at kind of being evasive and not trying to when you try to red team it or adversarially prompt it. But then there are examples of other models that can even these large models that are out in the open would generate really bad and harmful text, which would persuade people to harm themselves, or tell them to harm other people. Also, with these models becoming agents and interacting with the browser, they can do things that can have physical consequences, right? Right now you can connect it to, it can work as an interface to any application. If you can order a coffee, you can also order chemicals, you can order a lot of these different things, which could be used if there's a bad actor, could be used for a lot of harmful, building harmful products.
Do you think there's a reason, or there's an argument to have some sort of regulation in place? I know this is still an ongoing discussion, even at the highest levels, about whether needs to be regulated. There needs to be some sort of government body in place to think about the ramifications of this, and what sort of policies need to be enacted. What do you think about having some sort of over over sort of body overseeing AI development?
Yes, so I think there is definitely a need for a regulatory framework, and I think the first step is to basically involve all the stakeholders. So whatever is, if it's a body or organization or the government, I think they should involve all the stakeholders. That could be not just the developers or the people who already own these powerful systems, but also people whose data is being used, or people who's gonna be for whom the judgments is going to be used. So like, if if like, the simple example is like this credit approval systems, right? And we have seen like disparate impact of that, where like AI was used to like used for credit approval, and it could basically have disparate impact on marginalized groups. And so like definitely there's a need, but there's also this problem of almost like you're kind of trying to chase this target, which is this large language model capability, and design a regulatory framework for what the capabilities look like today. And that's just a snapshot, right? And by the time you have a framework in place, a best practices, risk analysis, auditing, all these like different things, and then when you actually like by the time you release those, because of the pace at which things are moving right now, probably the like the capabilities of these models are way more ahead and look very different from what they are today, maybe like 6 months down the line or 1 year down the line, when we do actually have a framework in place. So it almost seems like we do need that, but then how do we think about this problem from like a policy standpoint, like chasing this sort of a target which is continuously moving.
There's obviously, going back to what we spoke about with the stuff with Hugging Face, but also just the closed source aspect of what ChatGPT is now like. We've got Bard coming through as well. Again, very closed up and controlled by a lot of these large corporations. Now, I've been thinking about this for a while, and I'm trying to understand a little bit about what the future might look like between closed source and open source, and who will triumph. It goes back to the era of sort of Linux versus Microsoft, right? And there was this massive community around building an open source operating system. And I feel like there's little analogies that can be taken from that to what we're seeing today. How do you see the landscape changing when it comes to the sort of the closed source solutions we know of today that are super popular versus the emerging ones that are now being developed open source, that can be developed on a Raspberry Pi, that are now starting to really understand? And I guess these developers have access to these resources. They can even train their own models. you know is there one that's going to triumph over the other? Is there going to be coexistence between closed source and open source AI models? How do you see this changing over the next few years?
Yes, I think it's hard to predict over the next few years, but I can maybe predict over the next 1 year or over the next few months, which I think I see them as coexisting. And that's mainly because I think a lot of these bigger models are more like general capability model, right? And so they're more sort of like able to like do very well on a lot of tasks. But a lot of people don't need these huge models for their use cases, which are very narrow and very specific. And so all they need is that I want them to be able to like be a scheduler, or like be able to write emails, like very specific use cases. And you don't need like a huge, it would be like a yeah, it would be an overkill to like deploy GPT-4 for that, right? And so there's definitely an appetite for much smaller open source models that people can like just fine tune on their data or like their use cases and use them. And like you said, like with all the technology on like parameter efficient fine tuning or LoRa and all these, like you can fine tune them on your laptops. Like you don't even need probably GPUs, and you don't need access to the cloud for that. And so now they are on our phones, like these large language models. And so I think and that is all because of open sourcing models. Like the research and innovation is accelerated and made so much progress that now we have this technology available on such smaller scale and be able to perform at the level of much on some of these very big models.
Yeah, and that eventually ties back into sort of the whole regulatory side of things. Is if everyone has now the capability of developing their own models, and to them it's probably closed, and they can sort of do things that are very specific and niche, then they could potentially sell those models and monetize them, and for both positive and negative purposes. So it'll be interesting to see exactly what this space will look like, at least in the next year or so, because it's changing so quickly and changing so fast. It's one, it's hard to keep up, but two, it's exciting but also concerning at the same time. Are you concerned at all about the sort of the prospect of certain bad things happening, or do you want to continue to double down and go as fast as possible and see what happens?
Um, I mean, it does definitely bother me that, I mean, and I think that is kind of expected that there might be some of these moments in the next year or so where, we suddenly realize that, oh, this is not at all what we expected this to be. And it could be like learning moments. And I think that has happened a lot, like, as technology has evolved, like, and in general in humanity over the years, like, people realize, something that they deploy, they realize that, oh, it doesn't work this way, and then you change, you pivot. And so I think like knowing like when to pivot, when to like when to, or like when to keep going, I think is kind of essentially the key. But yeah, I think so far I don't see like an existential risk with these large language models. But I do foresee that there would definitely be like times in the coming months or coming year or so where they would be like, oh god, like we did not expect this to happen with a language model, and this is something that we should have, maybe should basically like make, put a guardrail for this, or like double down on this and see how we can fix this. But and what that would be is something that is unknown at this point.
Let's quickly just finally talk about maybe AGI, just very, very quickly. Maybe explain again what is AGI and when do you think we can reach AGI?
So AGI stands for like artificial general intelligence. It's basically like being able to like do a lot of tasks like like humans do at or like much better than humans, like at like a super intelligence level. I would say like I don't think we have AGI right now, although we are seeing sparks of AGI with GPT-4 in the sense that it is able to like do really well at a lot of these tasks, learn and transfer from like what it has learned from a task to a, like a new task. And I think a lot of these point to a model that is like generally capable of doing a lot of these different tasks without being trained to like do any of these tasks in specific, in particular. And so but I like it definitely had lacks a lot of these things, and like common sense reasoning, again, like a lot of people have evaluated. And I would recommend Agent Choi's TED talk on this, and she gives like very concrete examples of how GPT-4 fails on common sense still. And then there's also like this question on like people have can like write a proof for theorems, like probably GPT-4 still can't do it. It is not able to even backtrack, and that is kind of one of the things that I'm like really looking forward to, like the next generation of language models, to like when they plan something, they take some actions, and then they realize that, oh, this is not the right thing. They are not able to backtrack. When you generate something and you keep generating it, like you're not able to like backtrack and figure out that, oh, this is not at all what like how this conversation should be going. So these are some things that I would say like is still lacking, that a human can very easily do.
Yeah, that notion of like going down and having this decision tree and then saying, okay, if this doesn't work out, then okay, maybe I'm going down the wrong path and I need to back up and then figure something else out. I think that's a very human trait to have. But eventually, I truly believe this will be something that GPT X in the future will be able to solve. Maybe let's quickly switch gears before we sort of wrap everything up here. I know that we spoke about a bit of your background into sort of getting to AI. There's going to be a lot of people listening to this. They're going to be AI enthusiasts. They're going to be engineers. They're going to be people who are out of college, maybe in high school, and they're excited about what they're seeing. Right? They want to get involved, but they don't know how to start, and they're saying they're using ChatGPT. They think it's awesome. They're trying to use all of these tools, and it's helping them in the best way that they can. But they want to contribute to the to what this could potentially be in the future. What advice do you have for those people who are looking to get into AI and don't know where to start? And maybe we can sort of talk about, what should they learn, what book should they read, what topic should they cover, just to get them headed in the right direction.
Yes, so I would say I think just going back to the foundations. So looking at statistical machine learning, I still have that book on like pattern recognition and machine learning. I highly recommend that. It goes from like the very basics, like very like the basics of math, algebra, and then all the way to like how does that help with like finding patterns in data. And so that's kind of like very basic building blocks of machine learning. Doesn't get into like neural networks and stuff, but still gives you like an idea of like why like data is important, like how machine learning helps with like finding patterns in data and so on. And then the next thing is to like learn about like back propagation, which is again like the horsepower behind like how neural networks learn. Then also like then talk like looking into transformers. It would be like, I think initially someone getting into AI, it would be hard to read papers and make sense of it. It took me a while to like read the transformers paper over and over like a few times just to like understand it completely. So I like someone getting new into AI, I would ask like recommend them to like maybe look at blog posts. I know there are like a lot of blog posts that visualize a transformer, give like gifs about it, like how it like block by block how it works at each step. There are also like courses or tutorials online on doing that. I think those are like extremely important. And now like with Hugging Face as well, like we have like a lot of these tutorials on like building your first model or like training your own model with the data sets that are available out there. So I think like after like building these foundation, training your model on like you start with a Jupyter notebook or a Collab notebook and doing a like I think very like gets you a sense of accomplishment, right? Like you build your first model, it's able to do this, and like you get so and so accuracy. And that's and I know this because I've been like teaching course with Codeise, and like I can see like when like these students like they finish a project, they actually feel like, oh wow, like they accomplished, even though it was just like maybe writing like 3 lines of code overall, right? Like but just like a whole end to end, seeing the thing going from nothing to like working and generating results is like gives you like a big sense of accomplishment. That is the thing that keeps you pushing. And I think once you have those things going, like like basically have these check marks done for like smaller projects, and that will keep motivating you. And then go into like these bigger models as to like trying to understand like how what is GPT-3, or like what makes ChatGPT so much better and friendlier compared to GPT. And like this whole idea of like instruction tuning and reinforcement learning with human feedback, I think those are much like topics that go much more deeper into like AI and like and large language models.
Yeah, I think that that's great advice. And I would also add to that is look, just get involved, just try to immerse yourself in the community. There's always people talking about it. And it's so easy now to get started. You just need a laptop and you can really just start to explore. And again, that proverbial rabbit hole, you're just going to go down anyway. And but it's a fun rabbit hole because you get to explore so many things, and you'll definitely learn so much from all the information that you just explained. And I'll try to put all the links into the description below on papers and books that people can get their hands on. Let's finish off with some quick questions on your part, because I think it's always fun to learn a bit more about the guest, but also learn a bit more about what drives you as well. So yeah, let's go with the first question. And the first question is, do you recommend any 1 to 2 books that you've read that really piqued your interest, that you'd love to share with the audience? It doesn't have to be about AI or anything like that, but anything that really gets you excited.
Yes, I think one book I would recommend is this Thinking Fast and Slow by Daniel Kahneman. It's about like it's not related, it's not AI, but it's very interesting. It talks about like how people think and how we have like these two systems in us, like system one and system two. And recently, I've seen people like compare those to GPT-4, which kind of is more like post talk much later. But I thought that was like very interesting, and when I actually read that, I'm like, oh wow, like yeah, now I'm able to connect that as well.
Next question is, how do you approach your day? And I know everyone is kind of different. I know that I'm kind of structured. I know a few people who are sort of go with the flow. How do you approach your day, especially when you are working on something big and meaningful, and you're sort of engrossed in the work? How do you make sure that you're on top of it, and you also can sort of balance that with your personal life as well? How do you approach your day to day from that perspective?
Yeah, so I would say I changed a lot since I became a mother. I'm a mom of 2 kids now, and I have never been this productive ever before. And I think it's just because you realize that you have limited time by yourself, and any time that you're away from your kids is very precious. And so you're like, I'm laser focused, and I think that's really helpful. But also, like I just get a sense of accomplishment when I do like smaller tasks and finish them. So if I feel like for example, writing, like, I start my day and I feel like just writing this and like finishing off would be like just tick marking a check, on my to dos would like, and that gets me, and it's still like 8:30 a.m. while I finish that. That gives me like a real sense of accomplishment. And so when I finish like say 3 tasks, and still 10 a.m. and I'm like, wow, okay, this is going great. Like this day is going so good so far, as opposed to like trying to debug something which, I probably spend already like a few hours. And so I think that is like, one, like that's one way I go about my day, is to like, try to finish few tasks and like finish, see it to completion.
Yeah, I always find like having a checklist and having the feedback of like, oh, I can cross this out or I can tick it off is just such a nice dopamine hit. And you feel like, okay, that's enough momentum to continue in the next one and the next one. So you just continue to sort of reinforce that cycle, which is very cool. The third one is, what do you do outside of work? I know that you have a family, young kids, but also I think that's also, to me, it's important to sometimes disconnect from work because it at the end of the day it does help. How do you approach your lifestyle outside of work?
I love biking and hiking and just going out, getting out there. I think like California is really great for this. So yeah, that's kind of how I almost like every day or like every other day I've been like go for like bike rides, get out there, like get some kind of like nature walk. And because I have kids and like I've been really like listening to this podcast about like respectful parenting. Like that's the podcast that I listen to right now. Is that like just like how it's very primitive, like it's for us to like go back to our primitive roots. It's like really helpful, like to be connected to where we came from, and really helps with like our day to day, and like the sense of like like what we are right now. And I think that's very important to me.
Very cool. And I agree. And I'm glad to hear that you're a biker. I'm an avid cyclist myself, so I hope that we can find the time when I'm back there to sort of go for a nice bike ride. And then finally, is what's the best way for people to connect with you?
I would say LinkedIn or Twitter.
And I'll put all of those links in the show notes as well, so they can reach out to you if they have any questions on whatever you're doing. So hopefully they'll be able to connect with you as well. Other than that, thank you so much, Nazneen, for your time. I know that you're super busy, and I really appreciate you coming on. And I'm sure a lot of people will get some really good value out of this conversation. So thank you.
Thank you so much for having me. Bye.
Thank you, everyone, for tuning into this episode. If you like this episode, be sure to check out more by subscribing to the podcast on YouTube, Spotify, Apple Podcasts, and more. Thanks for listening, and I'll catch you next time.